Then here, issues in hardware, software design and code design. So what are the issues you are facing while you are designing the hardware and software? Okay. So here in the embedded system design, you will be having two approaches. One is software development life cycle ends, and the life cycle for process of integrating the software into hardware begin. So once you are developing the software for your idea, that is your system, then you what you will do, you will start to doing or implementing hardware based on the software development. Okay. That is first step. Then second step, the both cycle, that is software development cycle as well as hardware development cycle, will be designing simultaneously, concurrently, will be proceeded. Okay. These two process, that is cycle, software cycle as well as hardware designing cycle, will be doing simultaneously. Okay. In first method, after doing software development only, you will be starting to do hardware development. Okay. But in the second step, you will be doing both the step, that is both the cycle, life cycle, will be beginning at the same time. Okay. These are the two approaches. So the final design, so after implementation you will be having the final, so the final design when implemented gives the targeted embedded system. Okay. So what you are targeting to do, okay, your process will be completed after final design and implementation. So you will be getting the final product. Therefore you have to understand, okay, software and hardware design and integrating both into a system. So to get a complete product, embedded product, you have to know or understand about the software and hardware design and how to implement both in a single system. Okay. அதே மாதிரி hardware software code designing are important aspect of designing embedded systems. So you have to know both the development, okay, hardware as well as software designing development. Okay. ஸோ ஹார்ட்வேரில் மட்டும் நல்ல இதாக இருக்கக்கூடாது, சாஃப்ட்வேர் மட்டும் தெரிஞ்சால் போதாது. போத் ஹார்ட்வேர் அண்ட் சாஃப்ட்வேர் யூ ஹாவ் டு keep concentration on both. Okay. Then further there is hardware software trade off. What is trade off? So the hardware engineer must know the software development also. Okay. அதே மாதிரி software engineer have to know the hardware problems and development. Then only you can produce a good embedded product or sophisticated uh, time being embedded product. Okay. For example, CCD coprocessor Kodak execute fast when implemented by hardware, but the design cost will be very high. Okay. Because you are using CCD process and codec, so and the processor performance will be very high. Okay. So you have to consider both hardware and software while designing a embedded product. ஸோ சிசிடி கோப்ராசரில் மட்டும் கான்சென்ட்ரேட் பண்ணக்கூடாது, அதே மாதிரி கோடெக்ங்கிறது ஒரு சாஃப்ட்வேர். ஸோ அந்த சாஃப்ட்வேர் டெவலப்மெண்ட்டில் மட்டும் கான்சென்ட்ரேட் பண்ணக்கூடாது, ரெண்டுலேயுமே கான்சென்ட்ரேஷன் ஈக்குவாலிட்டியாக இருந்தால் மட்டும்தான் யூ கேன் ஏபிள் டு ப்ரொடியூஸ் குட் embedded ப்ராடக்ட். அதுக்கு எக்ஸாம்பிள் தான் இது. ஓகே. சிசிடி அண்ட் கோடெக், சிசிடி கம் அண்டர் ஹார்ட்வேர், கோடெக் வில் கம் அண்டர் சாஃப்ட்வேர். ஓகே. And then let us refer to an interview of Jean Louis Brillet. Okay. So in his article he given for a question, that is when they asked about the successful implementation of their product. Okay. He gave answer that software people must understand the nature of hardware design. So software engineer have to know very well about the hardware design also, and type of problem occurring in the hardware design while implementing software in the hardware. Okay. And also the hardware team have to know the um, good understanding of software knowledge. Okay. And applications. Okay. And the possibilities of and the capabilities of hardware uh, software problems have to be known by the hardware team. Okay, so both the teams, that is hardware team and software team, must have a good understanding of each other's language, that is hardware language and software language, and a willingness to adapt. Okay, they have to show the interesting on adapting. Okay, then only you can give the complete sophisticated embedded system product like Apple iPhone. Okay, this is software hardware trade off. Then choosing right platform. So software and hardware trade off only. So there is a trade off between the hardware and software. That is, hardware implementation provide advantages of processing speed. It is possible that certain subsystem in hardware controller, that is input output access circuit, real time clock, system clock, pulse width modulation, timer, and serial communication are also implemented by the software. So all this circuit, this hardware controller, input output memory access circuit, real time circuit, hardware mattum we cannot design, we can design by using software also. Okay, so you can change the all this block by using software. Okay, so yes, serial communication, real time clock, and timer featuring microcontroller may cost more than the microprocessor with external memory and a software implementation. பட் இந்த மாதிரி பிளாக்ஸ்லாம் பார்த்தீங்கன்னா அந்த ரியல் டைம் கிளாக் ஃபார் சீரியல் கம்யூனிகேஷன் அண்ட் டைமர் which will be using microcontroller will be costing while designing in the software, but it will be very low in hardware. Okay, இது மாதிரி you have to check the trade off between software and hardware, which will be suitable for hardware and which will be suitable in software. Okay, அது மாதிரி select பண்ணிட்டு தான் you have to do implementation, hardware and software implementation based on the advantages you are facing in software as well as hardware. Okay, so on selecting some few products, that is few blocks from the hardware, few blocks from the software, then after that only you are going to implement the complete system. Okay, so hardware implementation will provide certain advantages, that it will be holding reduced memory for the program, then chips will be in reduced number with a high cost, and then simple coding for device driver, and then embedded codes will be internally built out, which will be more secure than the external ROM. Okay, so these are the advantages while you are implementing hardware. Okay, so certain features and factors have to be considered while you are designing the product, that is software and hardware implementation. Okay, the next factors and needed features taken into the consideration. So while you are designing embedded product, you have to consider some factor and features. Okay, that is, we consider a general purpose processor or choose an ASIP. ASIP is application specific integrated processor. Okay, uh, that is microcontroller or DSP or network processor. Okay, application specific integrated processor is nothing but microcontroller or DSP or network processor. Okay, DSP, digital signal processor. So when the 32-bit system, 16 kilobyte plus on-chip memory and need of cache, memory management unit or SIMD, MIMD or DSP. This is nothing but a SIMD is nothing but simple instruction and then middle instruction. Okay, or DSP, that is digital signal processor instruction arise, uh, microprocessor, that is microprocessor or DSP will come under this memory management unit of processor. Okay, for example, video game, video voice recognition and image filtering system, it will need a DSP, because for audio signal and video signal you have to do some process on the processor. Okay, so that means digital signal processor will do the certain process and voice signal and image signal. So here you will be selecting the DSP processor instead of the general purpose processor. So based on the need, okay, need of the system, you will be selecting the processor, which processor will be apt for that particular system to design. Okay, அதுக்கு தான் ஒரு குட் எக்ஸாம்பிள் வீடியோ கேம் அண்ட் வாய்ஸ் ரெகக்னைசேஷன் அண்ட் இமேஜ் ஃபில்டரிங். ஓகே, and then microcontroller will provide the advantages of on chip memory and subsystem of the timers. A microcontroller available at a reasonable will may not support these on chip needs, then decide which one will suffice, that is 8 bit or 16 bit or 32 bit ALU. So after selecting a microcontroller, what you will be checking, you will be checking for whether the microcontroller is 8 bit or 16 bit or 32 bit. So based on the memories you are selecting, okay, on the memory size, based on the memory size you will be deciding the 8 bit microcontroller or 16 bit microcontroller or 32 bit microcontroller, okay, which will be having arithmetic logic unit size. Okay, so these features will be considered after selecting the microcontroller. And then first selection is on chip memory. Okay, which is needed for the embedded system. Here you will be having chip memory. In the chip itself you will be having inbuilt memories as well as inbuilt timer, and then serial communication subsystem, and then lastly, that is third and fourth, you will be considering that system being designed. Okay, need to be considered input capture, that is interrupt and load time for the input, and also compare output on the interrupt with the load time. Okay, then fourth one is ADC, and then read and write control signal. Okay, you this has to be checked. And then lastly you will be checking for uh, ADC on chip availability. Okay, that is analog to digital converter, digital to analog converter. That will be checked. That is whether it is inbuilt or not. Okay, that have to be considered lastly. So latest versions for 8, 16, 32-bit microcontroller can be found on the website of the Xeons, ARM, Intel, Motorola, Philips, and Microchip. So you can find the latest version on in these companies. Okay.